Was there a time that your eyes didn't work perfectly and it was hard to see certain things? Luckily, when we have changes in vision, we now have the technology to help us improve our vision, whether it's close up or far away. So after light enters the eye, we have to do our eyes have to do a job of focusing the image, or else we would just see blurry nothingness that kind of doesn't give us any information about what's in our environment, so it doesn't help us survive. So focusing our images is a really important part of the function of the eye. So as light enters the eye, it's bent towards the pupil by the cornea. So this is the first step in focusing the image. And then as light enters the cornea, through the cornea and through the aqueous humor, because liquid is denser than air, it is refracted or bent towards the pupil, the opening. And then it is bent towards a focal point at the back of the eye. And then an inverted image is projected on the light sensitive retina. And this inverted image doesn't really matter because our brain just reverts everything around because of our brain structure, our brain's information system. So the lens is flexible in our eye and it can change shape to allow us to focus on fine close-up objects or far away objects. So when we're focusing on a far away object, our ciliary muscles relax. So these are the muscles that control the shape of the lens. And then when the ciliary muscles relax, the ligaments, the suspensitory ligaments become tight and they end up flattening our lens. And so this is when we're looking at a far away object. So our ciliary muscles are relaxed. Those ligaments become tight because the muscles relax and our lens flattens. To focus on a close-up image, our ciliary muscles contract. Now those suspensitory ligaments can relax and our lens becomes more rounded. Now this is known as accommodation. So our next slide will be an image. So we have those relaxed ciliary muscles in the top left. So we have tight suspensitory ligaments and a flat lens. On the right-hand side, we have the contracted ciliary muscles, loose suspensitory ligaments, and a much wider, fatter lens. The importance of accommodation becomes more pronounced with age because as the years add up, so do the layers of transparent proteins covering the lens, making it harder. By about the age of 40, a lot of people have lost some of their accommodation reflex. And so middle-aged people will often need reading glasses for near vision, so that for near vision, so like reading newspapers, reading their phone, reading menus, because those ciliary muscles don't contract as well anymore. They get tired after the years, and it's also harder for them to contract the lens. A secondary adjustment occurs during the accommodation reflex. When objects are viewed from a distance, the pupil will also dilate, letting in as much light as possible. And when objects are viewed close up, that pupil constricts in an attempt to bring the object into focus. So we're getting less information. So again, as people age, their ciliary muscles will become a little bit weaker as well as the lens becomes firmer, and it's harder to contract those ciliary muscles, making that lens become round and globular, making it more difficult to look at objects that are close up. So looking at some conditions that can affect the cornea and the lens. So one of them is known as cataracts. So as the lens starts to age, its protein structure can degenerate, making it opaque. So this is like a frosted block, and it makes it more difficult for light to pass through. So one of the ways they correct cataracts is through a lens transplant. So they'll take your lens out and put in a new lens into your eye. Another one is known as astigmatism, and this can be more of an inherited condition. So some people are just born with a little bit more astigmatism than others. And this is the uneven curvature of part of the cornea. And so it affects how light will focus onto the retina. And this is typically corrected with glasses or contact lenses. So looking at nearsightedness and farsightedness. So more common in teenagers and young adults is being nearsighted. So you can focus clearly on close-up objects, but you cannot focus on objects that are as far away. And this can be caused partially by an elongated eyeball. So this is when the eyeball might be longer than your lens can focus light. So the focal point will end up falling in front of the retina. And this is corrected with concave lenses, so lenses that are curved inwards on both sides. And this is known as myopia. And again, common in teenagers and young adults. Now, less common in teenagers, but more common in people who are middle-aged or older is hyperopia or farsightedness. Now, this is when people can see clearly objects that are far away but can't focus on objects that are close up. So, this can be caused because your eyeball is too short or because your lens can't focus enough, flatten enough to focus light onto the retina any longer. And images will focus behind the retina, and this is corrected with convex lenses, so lenses that bulge on both sides. Additional vision defects include glaucoma, which is a buildup of aqueous humor, so the humor in the front of the eye, which then causes a blockage, and it causes fluid to build up in the back of the eye, which can cause pressure on the retina. And if you have too much pressure on the retina, it can squeeze those arteries and veins off, which slow the blood flow in the retina, which can cause cell death. Now, if you don't get your glaucoma treated, neurons possibly could die, and you could have blindness as a result. So the tiny tear ducts usually drain any excess fluid out of the aqueous humor, but if it gets blocked, the fluid builds up and pressure increases inside the eye. And then those cells can die at the back of your retina. So here's an image of what people might see if they're slowly developing a cataract. So this is again when the lens becomes opaque. It makes it more difficult for light to get through and vision starts to get dimmer. So one of the first things you might notice is a difficulty seeing with detail at night. And so you can remove the lens and then fit that patient with strong glasses, but much more common now, they replace the natural lens with a plastic one, and they can also replace that lens with a prescription lens if you had glasses. So if you had bifocals, you might just be able to wear regular glasses, or if you only had one type of glasses, one prescription, you can get a prescription lens and then you might not need glasses at all. So another really interesting piece of technology is snow blindness glasses. So if you've ever been outside in the snow, you might notice that when light reflects off of it, it gets very bright. And because we have those light sensitive pigments in the back of our eye that become more, they need time to recover. Inuits developed a snow blindness glasses. So they would take birch bark or bone, cut thin slits into it to only allow a small portion of light to enter the eye so that the fovea centralis in the retina doesn't get overwhelmed, so that they can continue to see all day, even in the brightest of days. Well, thanks for finishing up today with the way we see with our eyes and some vision defects. I'll catch you guys next time. Bye.